Okay, so first off, we have to do our free body diagram. Always start with this when you have to do physics problems with forces. Will make your life so much easier. So you have the y-axis and the x-axis, like normal. Then we have to draw and label all the forces that we are given and are trying to find. So first off, we have our one given, which is going to be F tug. Now, the force of the tug is going to make an angle of theta with the x-axis. Then we know we have to find an unknown force, which we will call F2. Now, F2 makes an angle of phi. What we're trying to find is going to be F sand, the force of sand on the boat, which we'll notice is only going in the negative y direction, which will be important later. Also, we have to know that F net is going to equal 0 because the velocity is constant throughout the entire problem. So F net equals 0, and we know we have all these three forces. So if the net force equals 0, we know that all three forces have to also equal 0. So F net equals 0, which equals the force of the unknown. That makes it sound really special. The force of the tug and the force of the sand. Okay, so the following thing that you have to do is split the net force into components. So we know we have the net force in the x direction, which will be the force of the tug in the x direction minus the unknown force in the x direction. Also, we have the net force in the y direction, which is going to equal the unknown force in the y direction plus the force of the tug in the y direction minus the force of the sand. And it's only the force of the sand because on the free body diagram we know that the force of the sand is only in the y direction. Okay, so we have to use this equation to solve for the force of the unknown. So first off, we have to find what these are. So if you look back down at your free body diagram, what we're going to be looking for is the x component of tug and the x component of F2, which you know you're going to have to use your sine and cosines to do. Now, when we do this, coming back to the other board, we're going to get 0, because remember F net is always going to equal 0, equals the magnitude of F tug times the cosine of theta subtracted by the magnitude of the unknown force times cosine phi, which we just get this from trig. And then we have to solve for F2. So when we're solving for F2, we use that equation, and we're going to get, do this in green, that the unknown force equals the magnitude of F tug times the cosine of theta over the cosine of phi, which we'll use in this equation. Okay, so we're going to do the same thing for the y components as we did for the x components, which, coming back down to the free body diagram, you look at it and you know that basically this for each respective force is what you're going to be trying to find, which is going to be the opposite of cosine, so woohoo, sine! Because sines are awesome. Okay, so coming back up to the original board, I'm going to get the black marker back out. And from trig, we see that F net is 0, which is actually not from trig. That's because we know, remember, velocity equals constant, so F net equals 0. Okay, so we know the force, the unknown force, which we found already, we'll plug that in later, will be the magnitude of that times the sine of phi plus the magnitude of F tug times the sine of theta minus F sand. Following, we're going to solve for F sand and plug in our force that we found earlier. So when we do that, we get F sand will equal all of this fun stuff that we found earlier. So F tug, magnitude, cosine theta over cosine phi times the sine of phi plus F tug, the magnitude of that, sine theta. Now that's a pretty convoluted thing, so we're going to simplify that before we say it's our final answer. So in the end, we will get that F sand equals the magnitude of F tug times the cosine of theta times the sine of phi plus sine of theta times the, hate to do this to y'all, but cosine of phi up there, all over the cosine of phi. Also, this is going to be the magnitude of F sand because that is what we're trying to find. So this is your final answer.